Betelgeuse is so big that if you were to place it in our own solar system, it would stretch to the orbit of Jupiter.
It's so easy to think of our sun as this incredibly gigantic thing, but our sun is absolutely tiny compared to some of the giant stars in the sky.
A big, giant, dramatic end to a star's life.
What if I told you that one of the brightest stars in the night sky, Betelgeuse, is on the verge of erupting and poses a grave threat to life on Earth? In this video, we will cover the recent warning given by NASA's chief scientist about the potential explosion of the Betelgeuse star. We'll explore the details of the warning, the potential consequences, and what scientists are doing to prepare for this event. This is a must-watch for anyone interested in space and the future of our planet. By the end of this video, you will have a clearer grasp of the threat posed by the Betelgeuse star and the measures we can take to mitigate the potential consequences. This is information that could significantly affect our future, so it's essential to stay informed on this topic. Each second, billions upon billions of stars, including the Sun, generate enormous amounts of radiation. One of these stars, Betelgeuse, is dying, and its demise will be accompanied by one of the most intense explosions in the history of the universe. But what exactly is Betelgeuse? Betelgeuse must be mentioned whenever potent stars are discussed. It is a red supergiant star so enormous that it's one of the largest stars visible without a telescope. Betelgeuse is called Alpha Orionis, which is the name scientists assign to the brightest star in a constellation. However, Betelgeuse is actually the second brightest star in Orion, after Rigel. This must have occurred when Johann Bayer published the Uranometria Trio in 1603, where Betelgeuse became known as Alpha Orionis and Rigel as Beta Orionis. Betelgeuse is a variable star with an apparent brightness that varies from 0 to plus 1.6. It is the second brightest star in Orion and the 10th brightest star in the night sky. Betelgeuse is an isolated star that is not part of any star system. It's also considered a runaway star because it's not part of any star-forming region. Interestingly, Betelgeuse is only 10 million years old, which is quite young in comparison to the Sun, which is about 5 billion years old. However, Betelgeuse is an evolved star despite its age. It consumes fuel faster than the Sun because massive stars require a great deal of fuel to maintain their existence. If you could place Betelgeuse in the Sun's place, it would extend beyond the asteroid belt and beyond Jupiter, encompassing all the terrestrial planets, Mercury, Venus, Earth and Mars. Despite being vastly larger than the Sun, Betelgeuse is only 16.5 times as massive as the Sun and has 126,500 solar luminosities, making it appear bright. Since Orion is one of the easiest constellations to identify, many use it as a navigational aid to find other objects in the night sky. For instance, if you draw a line through the 3 stars of Orion's belt and extend it upwards, you will arrive at Aldebaran, the brightest star in the Taurus constellation. From there you can migrate to the Pleiades, and this is the same way you can follow Betelgeuse as a guide to finding other stars by connecting Rigel and Betelgeuse and extending it past the red supergiant, where we will arrive at Castor and Pollux, the 2 brightest stars in the constellation of Gemini. Betelgeuse's unmistakable bright red color makes it easy to spot. It is a red giant star after all. However, the best time to see the star depends on where you live on Earth. For example, if you live in the Northern Hemisphere, the best time to see the star is between January and April, when the sun is setting and the star is rising. Will Betelgeuse go supernova? What are supernovas and why would it be a concern? Supernovas are among the most spectacular celestial events. However, even though stars live for billions of years, they do ultimately die, but they don't go out quietly. Their demise is accompanied by the grandest of all spectacles, known as supernovae. When a star reaches the end of its life and erupts in a brilliant burst of light, a supernova occurs. Supernovae can temporarily outshine entire galaxies and release more energy than the Sun will in its entire lifetime. According to NASA, supernovae are the most powerful eruptions in space. Even without modern space observation instruments, ancient astronomers knew about supernovae. The earliest mention of a supernova is RCW 86, which Chinese astronomers observed in 185 AD. They claim the star remained visible for 8 months. Chinese and Korean astronomers spotted the explosion of the Crab Nebula in 1054, and historical evidence shows that the event might have been noticed by Native Americans in the US. The supernova was so bright that people saw it during the day. There are two varieties of supernovae, categories 1 and 2. Type 1 occurs in binary, two stars in orbit around one another systems, where one of the stars is a white dwarf. Type 2 results from the rapid collapse and violent detonation of a massive star. The other star can be anything from a massive star to an even smaller white dwarf. To undergo this type of detonation, a star must have at least 8 times, but no more than 40 to 50 times, the mass of the Sun. Astronomers have observed Betelgeuse's dimming for more than a century. Betelgeuse, a red supergiant star, has been observed repeatedly illuminating and dimming. Late in its existence, Betelgeuse expanded to an enormous size. Bubbles of material rose from the star's interior to its surface and descended again, altering the ratio of hotter to cooler material on the star's surface. These alterations caused Betelgeuse to appear brighter and dimmer over time. Within those 25 years, 3 astronomers, including an amateur astronomer who measured Betelgeuse's luminosity using a telescope with a diameter of 10 inches, they observed that Betelgeuse was dimming once more. Several months later, they realized that Betelgeuse had dimmed more than it had in the previous 25 years, and posted a message on a site known as the Astronomer's Telegram to alert other astronomers. Betelgeuse continued to fade until it reached its faintest point. At its brightest, Betelgeuse is typically one of the 6 or 7 brightest stars visible to humans in the night sky. However, by the turn of the 21st century, Betelgeuse had declined several spots on that list to become the 21st brightest. The scientific community began to take seriously the possibility of Betelgeuse undergoing a supernova due to a deviation from a pattern. Astronomers estimate, based on its mass, that the supergiant will go supernova when it is approximately 10 million years old, while Betelgeuse is likely approximately 10 million years old now. Scientists did not fully comprehend what was happening to Betelgeuse, despite their suspicions that all was not well. However, it was clear that the star was geriatric, or nearing the end of its stellar life. And with the help of the Hubble telescope, researchers were eventually able to paint a clear picture of Betelgeuse's condition. They discovered that a massive plume with a diameter of over 1 million miles, or 1.6 million kilometers, may have risen into space. This is the equivalent of a starquake, or more accurately, a shock that blasted out a 400 million times larger chunk of the star's surface than is typically observed in the Sun's coronal mass ejection. Despite the fact that this may not seem significant, the process actually liberates massive quantities of excess energy in the form of high-energy electromagnetic radiation, naturally occurring radiation that leads to the atmosphere surrounding the reconnection site gaining heat. We are discussing temperatures of 36 million degrees Fahrenheit, or 20 million degrees Celsius and higher. This temperature is astounding. Encompassing particles, including those in the now isolated loop of the magnetic field above, receives a tremendous increase in velocity and energy, which produces a massive bubble of expanding heated gas that escapes the star's influence. Once liberated from the influence of gravitational force, the hot gas races across space at velocities of hundreds of miles per second. So when scientists noticed large amounts of material ejected from Betelgeuse, they had never before witnessed such a massive mass ejection from the surface of a star. It was like witnessing stellar evolution in real time. The research also incorporated information from a variety of other sources. Stellar observatories such as the robotic Stellar Observatory in Spain's Canary Islands and NASA's Earth-orbiting spacecraft are pieced together to form a stereo image aboard a spacecraft. Various categories of data scientists were able to assemble a narrative of the explosion and subsequent events. One of the consequences of the eruption was that a portion of the photosphere, the lower atmosphere of a star, was blasted off, leaving the star with a thinner atmosphere. Before the eruption, Betelgeuse exhibited a pulsating pattern of dimming and brightening on a 400-day cycle. This cycle has ended, at least temporarily. In 3 months, Betelgeuse's southern hemisphere lost roughly twice as much material to its surrounding space as usual, but the superheated plasma cooled substantially after traveling millions of miles from Betelgeuse. At 200,000 miles per hour, it condensed into dust particles and formed a cloud. Using ultraviolet data, scientists were able to determine when the outer atmosphere of Betelgeuse returned to normal, even though they were still observing the dimming through visible wavelengths and while everything seems to be back to normal, in the outer atmosphere the star's surface may still be jiggling like gelatin. So what will happen when Betelgeuse eventually explodes as a supernova? Scientists are unable to predict the specifics, but using sophisticated simulations, they've been able to provide a fairly accurate depiction of the last days of Betelgeuse and what it will mean for Earth. They obtained data for their model from supernova 1987A. When the inevitable occurs, Betelgeuse will shine as bright as the half moon or about 9 times fainter than the full moon, but scientists will be prepared for the event beforehand. Instruments on Earth would have detected neutrinos or gravitational waves, which would have alerted scientists to the impending event. Concentrated into a single point, it will be so dazzling that you'll be able to see it during the day for approximately 1 year. The bright spot will remain in the sky, and of course it will be visible to everyone. And as the supernova fades, you'll be able to see it at night for several years. With a star that's visible during the day for such a long time, you can be certain that it will generate a great deal of interest. With the advanced warnings scientists expect Betelgeuse to provide, many people will be waiting for the explosion to begin. When the process is complete, sky gazers will notice a difference in the Orion constellation. The left shoulder of the constellation will be absent, and individuals will have to rely on other stars to locate stars in the night sky. But will humans be affected? Will radiation from the explosion reach us? There is no need to worry about Betelgeuse's supernova. For a supernova to have a significant impact on us, it must occur relatively nearby. A universal distance measuring system based on a few dozen light years, thankfully Betelgeuse is considerably further away than that from us. More than 700 light years distant, so we can relax and enjoy the show. That does not mean that there are no effects on the planet. For example, the supernova from Betelgeuse will affect animals, particularly those that use the moon for navigation and are easily confused by artificial light. Even though they are eager to observe the supernova, astronomers will be impacted. It will disrupt their sky-watching schedule. When the moon is bright, it is difficult for them to see other celestial objects. Therefore, when Betelgeuse persists in the sky, there will not be enough darkness for them to work, and even studying Betelgeuse will be difficult due to the moon's luminosity. Ground-based telescopes will require modifications to their instruments to manage all that data. They will likely be required to collect less. When is this likely to occur? That may not occur in the lifetime of those viewing this video. Betelgeuse may still be active in 100,000 years if the massive star is still in existence. Burning helium at its center indicates that there is still ample time. What do you think? Would you like to witness a supernova? Let us know in the comments, and if you enjoyed the video, please like, share and subscribe. Don't forget to hit the notification bell to be notified each time we release a new video. You could also check out the next video on your screen. See you there.